Welcome to Learnpedia, the ultimate JEE and NEET prep tool that is currently being used by over 20,000 aspirants. Let's see if you can answer this actual NEET question. If you think you got the answer, then post it in the comment section below. To understand the concept behind this question, watch the video that follows.
So among the various methods of preparation of amines, we have Hofmann's bromamide reaction or degradation. What is this Hofmann's bromide reaction? So in this Hofmann's bromide reaction for the preparation of amine, the starting material is amide RCONH2. When this RCONH2 is treated with bromine and concentrated aqueous KOH solution, that is bromine in the presence of KOH is nothing but potassium hypobromite, KOBr, K plus OBr minus as the reagent. Then primary amine is formed with the byproducts potassium bromide and potassium carbonate and water. Since potassium carbonate contains one carbon atom is lost from amide, and the amine formed will have one carbon less than the number of carbons in an amide. Therefore, the method is considered to be degradation, decrease in number of carbons. So in this Hofmann's bromide method for the preparation of primary amines, one carbon less than the number of carbons present in amide. So therefore it's called degradation. So the reaction involved is the amide RC double bond O NH2, that is alkanamide is the starting material when it is treated with bromine in concentrated aqueous KOH solution, which on heating gives RNH2. So this alkyl group with amino group will come out and one carbon is lost in the form of carbonate. So thus primary amine, 1 degree amine becomes the product of the reaction. Along with potassium coming out with bromine as potassium bromide and K2CO3. So therefore to remove two bromines which is added in the form of Br2, two KOH molecules are needed, and likewise K2CO3 contains two potassiums, hence total number of moles of KOH needed is 4. So that it is 2 KBr K2CO3 plus 2 H2O. So this is what is the reaction and these are the byproducts. Say for example, let R is equal to CH3. We cannot put R is equal to H. That is formamide cannot be used. In that case, ammonia will be formed. So to get primary amine 1 degree amine, R must be equal to CH3. So therefore, if R is equal to CH3 in the above general equation, the starting material becomes acetamide, CH3 double bond O NH2 containing two carbons known as acetamide or ethanamide. This when treated with bromine with concentrated aqueous KOH and heat it, so that it is methylamine, methanamine, the primary amine, that is 1 degree amine becomes the product. Along with K2CO3, potassium carbonate, one carbon is lost in the form of potassium carbonate from the amide and 2 KBr plus 2 moles of water. Similarly, if R is equal to C2H5, example 2, so that propionamide C2H5 C double bond O NH2 is an example of amide and it is allowed to react with bromine with same concentrated aqueous potassium hydroxide KOH solution on heating, where this bromine mixed with KOH is nothing but KOBr, K plus OBr minus, hence it is potassium hypobromite. Therefore this reaction is sometimes called hypobromite reaction or Hofmann's bromamide reaction. So the product of the reaction is C2H5NH2, ethylamine, ethanamine, that is C2H5NH2, and bromines are given out in the form of KBr. The carbon will come out in the form of potassium carbonate and water is the byproduct. That's how primary amines can be made by using Hofmann's bromamide reaction. And since bromine and KOH reacts to give KOH, bromine reacts with KOH to give KBr and KOBr. So the reactive intermediate is K plus OBr minus. And this OBr minus is the active species during the reaction and is called hypobromite ion. Hence, the reaction is known as Hofmann's hypobromite reaction or simply Hofmann's bromide reaction. And this reaction in fact can be carried out even by using NaOH in the place of bromine. Therefore, bromine in the presence of NaOH can be the reagent or sodium hypobromite can be the reagent. Then what is the mechanism by which this reaction goes? So when we go for this amide RC double bond O NH2, where these two hydrogens which are attached to nitrogen, which is more electronegative atom, and allow it to react with bromine in the presence of alkali OH minus. So this OH minus will come and attack this H plus. Therefore, it is the water that is eliminated in the first step to give RC double bond O NHBr. N-bromoamide becomes the product in the first step. And now this bromine halogen pulls this electron pair towards itself, and it is the C double bond O group, electron pulling group. So therefore it also pulls this electron pair towards the carbon. Hence this hydrogen which is attached to nitrogen is much more acidic than the hydrogen attached to nitrogen of amide. So therefore in the next step, this OH minus from KOH further attacks that hydrogen, and thereby once again water is eliminated. So thus the bond between nitrogen and hydrogen is pulled more towards the nitrogen atom, making this hydrogen acidic. So therefore it is the OH minus that will readily attack this acidic hydrogen, so that water is eliminated and give RC double bond O NBr. But it is the H plus that is lost, so the electron pair will be remaining on the nitrogen atom. So nitrogen will be carrying the negative charge. Nitrogen is one of the more electronegative species. Carrying the negative charge is not that stable. So thereby a rearrangement takes place where this electron pair will be coming in between to carbon and nitrogen. So this alkyl group with electron pair will go and attack nitrogen, and Br minus will be coming out. So the Br minus will be eliminated. So thus it is the Br minus that is coming out, and alkyl group is shifting to nitrogen and forming Rn. So alkyl migration is there from carbon of the amido group to nitrogen and giving Rn double bond C double bond O, which is one of the important reactive intermediates during this reaction and is called isocyanate. So isocyanate is the reactive intermediate during Hoffmann's bromide or Hoffmann's bromite reaction. Now this, in the next step, this isocyanate now will undergo hydrolysis where the lone pair of oxygen will attack on the carbon, so that the pi electrons will immediately shift towards the more electronegative oxygen, so that it now becomes Rn double bond, and here the oxygen carries the positive charge and it now becomes O minus. And we know this positive charge is nullified, the H will shift, and now it will shift in this way, and then this pi electrons will shift onto the nitrogen, resulting in Rn minus, where this H plus will migrate to the nitrogen to give RNH, C double bond OOH. And now it is the carbon dioxide that is eliminated. As this OH bond shift in between to this electron pair will come onto the nitrogen, so that it will become this H plus will now shift to the nitrogen, and RNH2, the product in which we are interested, 1 degree amine primary amine, is formed with the liberation of carbon dioxide. That's how one carbon is lost from the amide, and hence it's called degradation. But the reaction being carried out in the presence of base, this CO2 will be absorbed by the alkali. So therefore the alkali which we are using is in excess, with which this carbon dioxide combines to form carbonate. So therefore it is K2CO3 and water will be formed. So thus RNH2, the product, remains same, and this alkali OH minus with which the carbon dioxide will combine to give carbonate, or otherwise we can say by taking excess it is potassium carbonate and water that will be formed. So that's how the final products are formed, and alkyl isocyanate is the reactive intermediate. This is the mechanism by which the reaction goes. So the reaction can be even carried out by taking an example of benzamide, C6H5 C double bond O NH2. This when subjected to bromine in the presence of alkali OH minus. It is this OH minus which will attack this acidic hydrogen, and thereby water is eliminated to give C6H5 C double bond O. This will remain same and now become NHBr, N-bromoamide. But further Once this is bromine atom, it's a halogen. It pulls the electron pair towards itself, and this is the carbonyl group. It can pull the electron pair towards this side, and therefore this electron pair will move in this direction, and hence this electron pair between nitrogen and hydrogen will be more shifted towards the nitrogen, and this hydrogen becomes much more acidic now. And hence once again it is the OH minus that will attack this acidic proton. Water is eliminated and the lone pair will be left over on the nitrogen, giving C6H5 C double bond O, which will be remaining N minus and Br. It is this nitrogen carrying the electron pair will now be shifted in between two carbon and nitrogen, so that this phenyl group with electron pair will attack the nitrogen. Thus phenyl transfer is there from carbon to nitrogen, and this bromine with electron pair in the form of Br minus will come out to give C6H5, this one, which is now connected to nitrogen with a double bond C double bond O. So this is the reactive intermediate phenyl isocyanate that will be formed. Then this will be attacked by the water, HOH on carbon. So therefore this will go and attack this carbon, and hence this pi electrons can shift towards the O minus, and it will finally result after rearrangement to give C6H5 and NH, C double bond OOH, which is a carboxyl group, strong electron with a drying group. So that this electron pair will shift it here, and this electron pair will shift onto the nitrogen. Carbon dioxide is eliminated, which will be absorbed by KOH to give K2CO3 and water. So thus elimination of carbon dioxide is taking place. One carbon is lost in the form of carbon dioxide, hence degradation takes place during the reaction to give aniline, an aromatic amine. C6H5 NH2 is obtained, and the byproducts, as CO2 is absorbed by KOH, we can get K2CO3, and the Br minus which is given out is in the form of KBr plus water. So this is the Hoffmann's bromide reaction to get aniline, benzene amine, amino benzene from benzamide. Note that the reaction can also be carried out by using bromine in the presence of NaOH, and further this bromine reacts with NaOH to give NaBr and NaOBr. So therefore we can as well use Na plus OBr minus indirectly, that is sodium hypobromite is the reagent that is to be used to bring about Hoffmann's bromide reaction. Further, this is considered to be the most convenient method in the laboratory to get pure primary amine containing one carbon less than the amide. So, most convenient laboratory method for the preparation of both aliphatic and aromatic primary amines, that too in pure form.
Hey there, hope you understood the concept. Here's the answer to the question that was asked in the beginning. Found this video useful? Hit the like and share buttons to enjoy more such videos. LearnPedia's JEE and NEET prep tools contain over 4,000 videos and over 20,000 questions. You can access them online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of the product before buying.